Cosine, cosine, tangent, there's 6 trig ratios. They're all ratios. Ratios is another word for a fraction. Okay. They all go with right triangles, only right triangles. There's different kinds of triangles. There's scalene triangle, isosceles triangle, equilateral triangle. We're not talking about any of those. We're only talking about right triangles. So a right triangle looks like this, okay? Or it can look like this, or it can look like this, different ways, right? But essentially it has parts. 2 of them are legs. So it has leg and a leg. Those make up the 90 degrees. And then it has a long side, hypotenuse, right? Okay, those are the parts of the right triangle. And then it has a right angle. Usually they have a little box where it has the right angle. Okay. Okay, so sine, cosine, tangent. So sine, S-I-N, it's short for sine. Okay. It's not sin. Okay. It's not church. It's a sine. Sine. Okay. So, and the next one is cos. It's not cos. It's cosine. Okay. And then tangent. Tangent's the next one. So these are all the abbreviations. You look at your calculator, you will have these buttons. Okay, they're just abbreviations. Then we have cosecant, secant, cotangent. Okay, they all share a lot of parts. They all share a lot of parts. So if you look at these guys here in front of you, you see a lot of the same words. Hypotenuse, we know what a hypotenuse is. Alongside. Opposite, adjacent, we'll talk about that in a second. Okay? They share a lot of the same words. What do you notice about sine and cosecant? They're fractions. They're flipped. Reciprocals, yeah. They're reciprocals of each other. Same thing with cosine and secant. Same thing with tangent and cotangent. They're just reciprocals of each other. Okay? This little like it looks like a 0 with a line in it. It's a fancy X. You know, like X, like you don't know something, like X, like I'm trying to solve for X. It's exactly. It's just it's a in trig they use this instead of X and Y a lot. It's just a fancy X. It's a Greek letter. It's called theta. Okay, so that's all it is. It's not anything new. Okay, it's just we don't know it. Okay, all right. Some of your teachers might have taught you about SOHCAHTOA. SOHCAHTOA. It's kind of like a way to remember how to do sine, cosine, and tangent, right? It says sine is equal to opposite divided by hypotenuse. Cosine is equal to adjacent divided by hypotenuse. And then tangent is equal to opposite divided by adjacent. SOHCAHTOA sometimes. You don't have to memorize it because you can use your notes. That's why it's all in your notes. Okay, so I don't expect you to memorize it because you don't have to. I expect you to know how to use it, which we're going to do today. All right, so let's go down to example number 1. Example number 1, okay? So example number 1 is a right triangle. It's got 3 angles, A, B, and C. C is the 90 degrees, right? And then it also has sides. Sides X, side Y, side Z. Okay. So the first one, anytime you do any of these, sine, cosine, tangent, cosecant, secant, cotangent, anytime you're going to do the ratio, the first thing you need to do is look for the angle. So the angle we're looking at right now is A. So I'm going to go find angle A on my triangle. It's right there. All right, angle A. Okay. Now that's where we're starting. We're starting with angle A. From angle A, I know that sine is opposite over hypotenuse. Okay, so let me go back to angle A. So if I'm at angle A up here, which side, not angle, which side is opposite? Y is opposite. Yeah, Y is opposite. Okay. Over hypotenuse. Hypotenuse is Z in this case, right? Okay, y over z, or y divided by z. Let's go to the next letter. Cosine of a, still at a. We're still at a, right? So now cosine is not the same opposite over hypotenuse. It's different. It's adjacent. What does the word adjacent mean? Next to, yeah. The person who's sitting next to you, they're adjacent. You guys are adjacent to each other. Mr. Yates is right next door. His classroom's adjacent to mine because we're right next door. Same thing with Mr. Aguila. He's on the other side. Okay? Adjacent means right next to. Okay. So let's look at A. Which side is right next to A? Yeah, it's actually going to be X. Why isn't it Z? Isn't Z close to it too? Z has a different name, right? Z special. Z has a special name. So the side that is adjacent to A is X. So we're going to put X over, and then the bottom part for cosine is hypotenuse. That's Z. Okay, so that's the ratio. Yes, sir. Oh, that's a good question. So what if it was the letter C here? That's a great question. What if instead of A, it had C, right? Because is it opposite of C the hypotenuse? Here's the thing. You will never see that. They will never ask you, if you want to see your calculator freak out, try to find anything cosine, sine of a right triangle, because it won't. The only angles that work are the angles that are not 90 degrees. Okay, so these only work for angles, a right triangle, but only works for the two angles that are not 90 degrees. Good question. Okay, so yeah, that's why you see A, you see B, you see A, B, no C. Where's C? Because that's the 90 degrees. We don't deal with that. Okay. All right. So tangent now. Tangent still. Now I'm moving to B. So now I'm moving. I'm going over to B now. B's down here. So now tangent is opposite. So what side is opposite of B? X. X on top over adjacent. Which side is adjacent to B? Y. Yep, not Z, because it's got a different name. That's hypotenuse. Okay. The next one, sine of B. Sine of B. Still at B. So sine, just like letter A, sine is opposite. So what is opposite of B? X. What is the hypotenuse? C. Look at B and D. Look at these two guys. They have the same answer, but they are different questions, right? Because we switched the angles. The angles have been switched. Okay. Okay, letter E. Still at B. We're still at B. Cosine. Cosine is hypotenuse. So if I'm at B, or sorry, not hypotenuse, adjacent. Which one's adjacent to B? Not X. Y. Next to, right? Next to. Uh-huh. Yes. Yeah. Yeah. So if I'm up here, if I'm down here, this one will always be adjacent. If I'm up here, this one will always be adjacent. The two legs. Every time. Yeah. Okay. So now the bottom of cosine is hypotenuse, which is Z, right? Okay. All right. For the next one, tangent of A. So now I'm moving again. I'm moving back to A. Okay. Tangent of A. Well, tangent is opposite. So what side is opposite of A? Y over X, which is adjacent to A. Okay, the next two are still at A. Now we're introducing the new ones. Probably didn't talk about these in Math 2. The cosecant, secant, and cotangent, these three, probably didn't do that in Math 2. It's more of a Math 3 thing. Okay, so here we go. Cosecant of A. So cosecant is hypotenuse first. Hypotenuse. So if I'm at A, hypotenuse is still Z over opposite. Y. Z over Y. Secant of A. Still at A. Secant is hypotenuse. Okay, Z. Over adjacent. What's adjacent to A? X. Good. And then the last one, letter H. We go back to B one more time. So the cotangent of B. So cotangent is adjacent. So what's adjacent to B? Y. And what's opposite of B? X. Good. Okay, that's essentially what we're doing today. The only difference is instead of X, Y, and Z, they're going to change it up and they're going to give you some numbers. That's all. Okay. All right. So let's move to the back, or the inside, I should say. Okay, so a little bit of review again. Pythagorean theorem. You probably have all heard of the Pythagorean theorem. We use it for, why do we use Pythagorean theorem? We use Pythagorean theorem for one reason and one reason only. When we don't know the side lengths of a right triangle. So if I'm missing one of these, if I'm missing a leg, or if I'm missing a hypotenuse, I use it. So how do I use it? Well, you take one of the legs and square it. Doesn't matter which one. And then you take the other leg and square it. Add them together. And then you take the hypotenuse and square it. And they should equal each other. Okay, so let's use that for letter 2A. Okay, so we got the two legs here, right? I got a leg here, and I got a leg here, and I got a hypotenuse here. So for 2A, which part is missing, the leg or hypotenuse? Your leg, yeah. How do I know it's a leg? Because, yeah, the two legs always make up the right angle, the square. Always, always, always. And the hypotenuse is always going to be across from the square. It's always going to be across. So I'm missing a leg, so I'll call that X. Since I don't know what it is, I'll call it X. Okay, so now I'm going to use the Pythagorean theorem. So take one of the legs. It doesn't matter which one of them. X, square it. Plus the other leg squared equals the hypotenuse squared. Okay, X squared plus 25 equals 81, because 5 squared is 25 and 9 times 9 is 81. How do I solve for X? What do I got to do next?
Take away 25 on both sides.
There you go. Take away 25 from both sides. I want to get X by itself. So I get X squared equals, borrow 56. How do I get X by itself? What's the opposite of squared? Square root. Square root. Now, does 56 have a nice square root, nice number square root with no decimal? No. So if it doesn't have a nice number, we have to look for pairs because it says simplest radical form. We don't change it to a decimal. No decimals. That's what this means here. Okay. So 56, square root of 56. Look for pairs. So what makes 56? 56, 8 times 7. Circle the 7. 8 times 2 is 8. Circle the 2, and then circle 2 more 2s. So 56, when I totally break it down, is going to have 2 times 2 times 2 times 7. All right, we've done this before, lots of times. It's a square root, so I'm looking for pairs. Today, you're only going to be looking for pairs. So I have a pair of 2s. I actually have 3 2s, but I can only use 2 of them. So I'm going to take out a 2. When I take out a 2, what's left?
7.
Which is 2 times 7, which is 14. 14 has to stay because 14 does not have a pair. That's when I know I'm done. I've simplified it enough. No more pairs. Okay? Because on Delta Math, if you put the square root of 56 as an answer, it'll say not simplified. Or if you change it to a decimal, it'll just say it's wrong because they want it with no decimals. Okay? If it says round, round, but these won't say round. All right, let's go to letter B now. Letter B, I'm missing a side. I'm missing the long side, the hypotenuse this time, right? I'm missing the hypotenuse. I got 2 legs. I just don't have an hypotenuse. Okay, so pick a leg. It doesn't matter which leg. 7. We'll take 7. 7 squared. Plus, this one's got two parts. It's got 4 and the square root of 2. It's okay. They're both going to be squared. And then since we don't know this, we'll call it x squared. Okay. 7 times 7? 49. Okay, so how do I square this guy here? There's 2 parts to it, right? There's a 4 and there's a square root of 2. The 4 doesn't have a square root, but the 2 does. So this is how you do it. First thing you do, you distribute the 4. 4 squared. What is 4 squared? 16, right? So I have a 16 first. And then what if I square a square root? What happens when I square a square root? They cancel each other out, yeah. Anytime you square a square root, the square root just goes poof, goes away. Nope, it could be any number. That could have been a 3 in here. That could have been a 3 in here. And it would just be 3 down here. Because watch, why does that work? Because if I have the square root of 2 times the square root of 2, that's the square root of 4, right? And what is the square root of 4? So it's just kind of a shortcut for that. I put them still in parentheses because I need to simplify it a little bit more. 16 times 2 is 32. I don't need to take away anything here because 49 and 32 are both on the same side. So when I add them together, I get 81. Square root. What's the square root of 81? 9. Nice clean number, 9. Done. Because 9 times 9 makes 81. That's a pair. Okay. All right, so that was a little pause. Now let's go back to number 4. 4 and 5 are just like the front side. We're looking for one of those: sine, cosine, tangent, cosecant, secant, cotangent. So on number 4, we're looking for cosine. We're looking for cosine of A. Okay, so I'm going to highlight A. That's where I'm starting at. And then so on the front, it said cosine was adjacent over hypotenuse. Well, what's adjacent from A? 3, yeah. 3 is right next to A. And the hypotenuse is the square root of 13, right? Okay, so this is where we have an issue. One of our math rules is we cannot have a finished answer where the root is on the bottom. It can be on top, that's okay. But one of our rules is we cannot have a root on the bottom. Okay? And we have a root on the bottom here. So if I were to put that answer in Delta Math, it would say it's wrong. How do we change it? Well, this is how we change it. We're going to multiply by a number. Which number can I multiply the square root of 13 by that would make the square root go poof, go away? Itself, right? Itself, right? Didn't we just learn that up here? If you square a number by itself, right? It goes away. So I'm going to multiply by the square root of 13. The top. Can I multiply 3 times the square root of 13 and make the square root of 39? Because 3 times 13 is 39. The answer is no. Yeah, it shouldn't feel right. You should just kind of feel like, no, there's something going on here. And there is. You can't multiply them because one's on the inside and one's not. So how do you write them? You just write one first and you write the other second. The bottom, you can multiply those. 13 times 13 is 169. Guess what happens when you put 169 square root in your calculator? What are you going to get? You're going to get 13. They go away, right? These guys are the square root of 169, which equals 13. Okay, so can I cancel out the 13s? I got a 13 on top and 13 on bottom. Can I cancel these guys out? No, because the bottom is a 13. The top, the square root of 13 is not 13. It's like 3.8 something. Okay? You can cancel out the 3 and the 13 if they had a GCF. But do 3 and 13 have a GCF? No, they don't. Besides 1, they don't have a GCF. So you're done. Okay? Do number 5 on your own. Try number 5. All right, so this one is sine of A. So A is where we start. Sine, if I go to my chart, sine is opposite. So what's opposite from A? 8. So 8 goes on top. Over hypotenuse. What is a hypotenuse? 12. So we didn't even need the root. That's okay. That's good. We don't have to deal with it. So just reduce the fraction. What do you divide 8 and 12 by? And you get 2 over 3, right? Done. Leave it 2/3. Don't change it to a decimal. Leave it like that. Okay. All right. All right. So let's go on the last side, the last bit of the notes. Number 6. Okay. So they say, given there is a triangle, there is one of these guys, there is a right triangle, who we already found tangent for. We already did that for you. When we did tangent of angle A, we get 5 over 6. So what do we know about that triangle? Opposite of A is 5. Opposite of, or adjacent to A is 6, right? We know that already. Okay. So in quadrant 1. So in quadrant 1 means everything is up in quadrant 1, means everything, all positive numbers. Okay. All of these today will be in quadrant 1, so you don't have to worry about the negatives. Find the exact value of cosine of A. So they want us to find cosine of A. That's the problem we have to find. In simplest radical form using rational denominator. All of that is just, if you have a square root in the bottom, do what we did on the last problem. That's all it means. If that needs to happen. So the first thing, I don't have a triangle here. I'm going to draw a triangle because I don't know about you, but it's easier for me when I see things. When I can see it, it's easier for me to visualize it. Okay, so the first thing I'm going to do is I'm going to draw a right triangle and I'll label it like how they've been labeling. So they called the top B, this A, and this C. Now, does it have to be that way, A, B, C? No, but I'm just going to use what they've been using before. Okay? And then they said, hey, when you're at angle A, the tangent should be 5/6. Well, tangent is opposite over adjacent, right? So opposite of A, there better be a 5. And adjacent to A, there better be a 6. Otherwise, it won't work. Now, I don't know the hypotenuse. I don't know what the hypotenuse is, so I'm going to put an X there. They don't tell me that information, so I'm just going to put an X there. Okay, so that's the given part, right? They already gave me that. So now what's the question? The question is, what is this? What is cosine of A? Okay, so cosine of A is adjacent, right? So what's adjacent to A? 6. Over hypotenuse. What is the hypotenuse? X. We don't know that, right? Well, in order to finish the problem, we have to know that. So how do I figure out, what methods am I going to use to figure out what X is equal to? Right there. Leg squared plus leg squared equals hypotenuse squared. Pythagorean theorem. Pythagorean theorem. Just like I did for example number 2. All right. So what do I know? Do I know 2 legs or do I know a leg and a hypotenuse? I know 2 legs, right? Because those 2 legs make up the right angle. Okay, so here we go. 5 squared plus 6 squared equals x squared. Okay, so 5 times 5 is 25. 6 times 6 is 36. If I add these two guys together, I get 61 equals x squared. Square root of 61. Does 61 have any pairs? I don't think it does. I don't think you can't divide it by 3. 4, no. I don't think 61 has any pairs. So I'm going to leave my answer like that, the square root of 61. So this is the same thing as the square root of 61 because there's no pairs in 61. If there was, I'd take them out. Okay. So now that I know that, I can change this to the square root of 61. But it breaks one of my rules. It says I cannot finish with the square root on the bottom. So what am I going to multiply the top and the bottom by? Square root of 61. So the top, can I multiply 6 times 61? No. So it's 6 and then the square root of 61. The bottoms, you can multiply the square root of 61 and then take the square root of that. Or you can just say, hey, it's the same number with the square root times the same number with the square root. You're going to get 61. Yeah, because 61, watch, I'll show you. 61 times 61 equals 3,721. And then if I find the square root, of my previous answer, I get 61. So it is 61. Okay. The 6 and the 61. So can I cancel out the 61s? No. 6 and 61, though, if I can reduce them, reduce them. But we just said 61 doesn't have anything that goes into it besides itself in 61. So we're... All right. Let's look at number 7 now. Let's look at number 7. Thank you. Draw a triangle. First thing I got to do is draw a triangle, just like I did. They give us some information, we're going to label it. Okay? I'm going to label it the same way. B goes on top, C goes down here, A goes down here. Doesn't matter. Doesn't matter. Yeah, I could have A up here and B down here. The only thing is B can't A. This one has to be C because they say this of A, right? So we don't want to mess with the 90 degrees. So you can switch these two, but C is always going to be this guy. Okay. All right. So they said cosecant of A. So A. Cosecant. What is cosecant? Cosecant is hypotenuse over opposite. Hypotenuse over opposite. So the hypotenuse is the top, square root of 57. Opposite is on the bottom. So that's going to go there. 7 is opposite. They don't give me this side down here. Down there here, I'm missing that side. Okay, that's the given part. That's what they've given us. Okay. So now what I'm going to do is I'm going to answer the question. The question is, what is tangent of A? Yep. Tangent is opposite, which is from A, the yellow, which is 7, over adjacent x. I don't know that. Okay, we'll finish it out. I need to know it. Well, I'm going to have to use leg squared plus leg squared equals hypotenuse squared. So what am I missing? What's the x? Is the x a leg or is it a hypotenuse? So leg. So you can go x squared plus 7 squared, or you can go x squared plus 7 squared. It doesn't matter which leg you put first, as long as the hypotenuse goes on the other side of the equal sign. I don't know. Okay, so x squared. 7 times 7. 49. What's the square root of 57? Squared is 57. Yep. Solve for x. Now I got to take away. Take away. 49. X squared equals, borrow, I got 8. Square root of 8. Does it have any pairs? I think it does. I think the square root of 8 is 2 times 2 times 2. So we can take out a 2, and that leaves a 2. So now we know the missing side is 2 times the square root of 2. So let's go put that back. Everywhere there's an x, I'm going to put a 2 square root of 2. Okay, well, again, that breaks a rule. That breaks the rule where it says we can't have a square root on the bottom. So here's a question. What do we multiply the top and the bottom by? Yeah, what's the only part that's causing the issue? Is it the 2 on the outside that's causing the issue? No, that 2 is fine. It's the square root of 2 that's causing the issue. So whatever is causing the issue is what you multiply by. So that's what I'm going to multiply by. So 7 times the square root of 2, is that the square root of 14? No, it's 7 times the square root of 2. The bottom, I have a 2, a regular 2. That stays. And then what's the square root of 2 times the square root of 2? The square root of 4. And what is the square root of 4? So I have another regular 2, which I multiply. So multiply, and I get 4. Because there was a 2 already there. Can I cancel out the 2 and the 4? No, I can't do that because the 2 has a square root. I could for the 7 and the 4, but they don't share anything in common besides 1. So you're done. You are done. All right. Okay. What I want you to do is do number 8. Do number 8 right now. Work on example number 8. If you're stuck, draw the picture. So I know I'm dealing with A. So secant of A. They give me secant of A. They say it's the square root of 13 over 2. Well, I go to my table and I see secant is hypotenuse over adjacent. So hypotenuse is the top number. Adjacent is the bottom number. That means I don't know this side here. Okay. I might not need it. Tangent of A. Well, tangent is opposite over adjacent from A. So I will need it. Okay, so I got to do some work to figure out what A is. So leg squared plus leg squared equals hypotenuse squared. Minus 4 from both sides. Take the square root. And this one gives me a nice clean number. 3. Okay. So go change x out for a 3. No more square roots. You don't have to deal with multiplying by a square root because there is no square roots in our answer. It's done. Okay. All right, let's do the last problem. We'll be done for today. Okay, so let's draw the triangle. Okay, so they say cosine of A is 5 over the square root of 61. Well, cosine is adjacent. Adjacent to A is this guy right here, right next to it. The bottom is the hypotenuse, square root of 61. So we don't know this leg over here. We have to use those to find sine of A. Okay. Okay, so sine from A is going to be opposite, x over the hypotenuse. So there's 2 issues here with sine of A. First of all, I got to find the top. And second of all, the bottom is a square root. Can't have that. Okay? So first thing I'll do is I'll deal with the top. So x squared plus 5 squared equals the square root of 61 squared. So x squared plus 25 equals 61. Subtract 25, and I get 36. Square root of 36 is a nice clean number, yeah. So let's go change x with 6. Well, that helps one thing. Now the other thing, square root of 61 is on the bottom, right? That was kind of a problem they gave us at the beginning, right? If you look at the very beginning, they didn't finish their answer. So we have to finish it. So the square root of 61, square root of 61. This one looks familiar, like one we've done before. Yep. Same answer as what we got earlier. Okay. All right. Okay. So usually we'd have 10 minutes, but because of the fire drill today, we'll tape tomorrow. So put them in your notebook where you're going to tape them. We'll tape them first thing tomorrow when we get